Hi, thank you for your interest in my presentation. I'm Maryam Mousavi, and today I'm going to talk about the safety and operational effects of different AV market penetration rates on an urban arterial nearby a driveway. So cities have been experiencing several growth and transformation over time, and transportation networks as an integral part of those cities have been experiencing the same trend. The growth in transportation network results in an increase in traffic congestion, fuel consumption, air pollution, and most importantly, number of crashes, fatalities, and injuries. Among different components of transportation networks, urban arterials are important because they connect major activity centers and they also carry high traffic volumes every single day. Along urban arterials, intersections are the most critical ones as they create the highest number of conflict points. That's why we decided to analyze the safety and operational effects of different AV market penetration rates on an urban arterial nearby an unsignalized intersection. To this aim, we developed our base scenario using BISIM. The base scenario was a 2,000 feet stretch of an urban arterial. It was representing only one direction of travel and a two-way driveway perpendicular to it and right at the middle of it. The speed limit of the arterial was set to 45 miles per hour and the driveway 20 miles per hour. We considered different AV market penetration rates and traffic levels of service to develop our scenarios. 4 different traffic levels of service of A, B, C, and D, and 6 different AV market penetrations of 0%, 10, 25, 50, 75, and 100% were considered. Combining different levels of these two variables, we got a total of 24 different simulation scenarios. And to capture the stochastic nature of the simulation models, we ran each simulation scenario 10 times with different random seeds. Eventually, we got a total of 240 simulation scenarios. After getting the outputs and manipulating the data, we analyzed traffic from 2 different aspects: operation and safety. Traffic operation was analyzed from 2 different aspects of traffic density and traffic speed, and safety was analyzed through rear-end conflicts using SAM. The results indicated that by increasing the traffic level of service, the traffic density started deteriorating. But within each traffic level of service, increasing the AV market penetration rate improved the density of the network significantly. In addition, the average speed of the arterial improved significantly by increasing the AV market penetration rate within each traffic level of service. Also, analyzing the number of rear-end conflicts indicated that by increasing the level of service up to level of service C, the number of rear-end conflicts increased. But at level of service D, we got a fewer number of conflicts compared to level of service C because it was harder for the vehicles to find enough gaps to conduct their maneuvers. However, within each level of service again, by increasing the AV market penetration rate, the number of rear-end conflicts decreased significantly. In conclusion, increasing the AV market penetration rate can improve traffic density significantly, especially at higher traffic levels of service, like level of service C and level of service D. Also, increasing the AV market penetration rate from 0% to 100% can improve the average speed of the arterial between 5% to 20%. And eventually, increasing the AV market penetration rate from 0% to 100% significantly decreased the number of rear-end conflicts by 84% to 100%. Thank you for your attention.